Okay, video number 2. So I thought we're looking back in the past, so we'll take a little journey, talk about some things. I figured my childhood and my past, I was a video game player, Legend of Zelda, awesome games. I broke out this sweet shirt to wear for video number 2. I hope you guys appreciate the true legend, I suppose. Anyways, I figured this class I'd like to reminisce about hour number 1 because, see, the seniors, you guys are going to be leaving pretty soon, and we're going to miss you, at least most of you. Yeah, so first hour, let's talk about some of my favorite moments. First of all, saying something that was grammatically incorrect and having Stephen Rand quickly correct me, or any of his crew, I suppose, like JR or Andrew Latham. Things like that. Other things, first hour, talking movies with RJ, pretty sweet stuff. Recycle Man Taylor Conklin every Tuesday and Thursday like clockwork. Also Kevin Noonan reminded me to do the attendance and not reminding me to do the attendance. Awesome. Gene Pryor calling me when I haven't done the attendance. Not awesome. But really, oh, and also Carter Klaus. How can you forget Carter? Falling asleep in the back of the room, falling asleep in the front of the room, showing up late almost every day. Just kidding. I don't want to pick on Carter. Although there was the one day where he showed up with a Jägermeister keychain and the Victoria's Secret lunchbox. That was classic. Good job, Carter. Anyways, I don't mean to go that route. But we will miss you, all of you. Oh, yeah. Best moment. First hour. Probably the best moment. One of my favorite moments. Harvest Food Drive. Canfort. Come on. You can't get much better than that. I think it's funny how some of our favorite moments have nothing to do with math. You may wonder how I sleep at night, knowing that you guys won't remember any of the math I teach you. Well, I hope you remember some, but you know, you'll remember those stories probably more so. Yeah, clearly I'm not sleeping at night because I'm up late making videos for you guys, because this may be what you remember. Pretty scary. On to problem number 2. Let's get going. So, what we've got here, this one's a little complicated, so I'm going to try to go a little bit, I'm going to pace myself. We've got a circle, equilateral triangles, all right, and so the first thing is we're going to create volume by sliding these triangles. So we're going to slide these triangles, that's the integral, from 0 to 3, because this is the equation of the circle is x squared plus y squared equals 9, so that's x squared plus y squared equals r squared. This tells us that r equals 3, so I'm going to slide from 0 to 3. So what I'm going to do is calculate the volume of half of this, and then I'm going to multiply by 2. So right away, I'm going to put a 2 right here, because I'm going to multiply all this by 2. In fact, I'll just put the 2 right here. What are we sliding? We're sliding the area of a triangle. The area of a triangle is 1/2 the base times the height. We're sliding along the x-axis, so it's a dx integral. Now let's talk about what this triangle is. First of all, it tells us it's an equilateral triangle, which tells us that each angle is 60 degrees. That's good to know. We know that here's the x-axis. This piece is y. If I solve for y, y equals the square root of 9 minus x squared. So that means that this piece of my triangle is the square root of 9 minus x squared. Which means that my entire base is twice that. So first of all, these 2's cancel. And so I have this 2 kind of the other part of my region. So I don't have to worry about that anymore. We're integrating from 0 to 3. This base is 2 times the square root of 9 minus x squared. That's the base. Now we have to figure out the height. Well, this is a 30, 60, 90 triangle. Notice how I said that this was also 9 minus x squared. If you look at part of this, right, based on our 30, 60, 90 relationships, we all know and memorize from our SATs and ACTs, the hypotenuse is twice that, so that's 2, 9 minus x squared. This is also 2 times the square root of 9 minus x squared. So you see how everything fits. The height then is this distance, just this one piece, times the square root of 3. So that's going to be the square root of 3 times the square root of 9 minus x squared. So I'm going to put a square root of 3 out here, and then another square root of 9 minus x squared dx. So the 2's cancel, base is the square root of 9 minus x squared. So that is this piece, that's the base, and this is the height. The square root of 2 is part of the base, the square root of 3 was part of the height. Alright, now we can move on. This becomes 2 root 3 times, well, these square roots cancel each other out. So I'm going to do a couple steps at once. This becomes 9 minus x squared, so the integral of 9 is 9x. The integral of x minus x squared is negative x cubed over 3. Evaluating from 0 to 3, this gives us 2 times the square root of 3 times 27 minus, that's 27 divided by 3, which is 9, so minus 9. So we get 18 times 2 root 3, which then gives us 36 times the square root of 3, which is answer choice E. I hope that made sense to you guys. We've got 3 more problems left, but I first got to do some juggling. So for these videos, or these tricks, I really felt like I had to think outside the box, and I was like, hey, I've got a box trick. Alright, so this is the box trick. Yeah, should be pretty self-explanatory why this trick is called the box. But anyways, we got to think outside the box. So we can take this ball that's created the base of the box and throw that ball through the box. Alright, so it goes like that. But I said earlier we got to think outside the box. So now I'm going to attempt probably the hardest 3-ball trick I know, upside down box. Right? Take this ball that's shuffling back and forth on the bottom and throw it above the 2 balls and keep it going. Maybe. We'll see. Here it goes. Woo. I got a couple rounds. Let's try again. That's good enough. Alright, also, I almost gave away this trick earlier. Thinking outside the box. Not only can we throw clubs, but we can catch clubs with clubs. This is the scissor catch. Alright, so it goes like that. And then we can be a little creative here. Throw that, catch it, cool shadows. Throw this, slide it. There we go. And that was video number 2. On to video number 3, 4th hour. You're next.